factoring all the way down to that x squared. All right. Using our Descartes, our rational zero theorem, we're able to get the possible zeros and then finally, again, coming up with those zeros. You saw in a few instances we had the x squared plus 2. Right? We actually had a number for the zero. Imaginary, right? So that's something we're going to be looking at today. We're not going to be looking at any more as far as we always use synthetic division and factoring to get to those zeros. But now we're going to look at if some of those zeros are complex numbers. Our complex zeros are always going to appear in conjugate pairs. If I have one complex zero, I know its conjugate is there as well. What is a conjugate again? A complex conjugate. Here's my one complex zero, a plus bi. What else? What is its complex conjugate? Absolutely. All we're doing is changing that middle sign. I don't put a negative on that a or anything like that. It's just if you take plus bi in front of that imaginary part, that's one that doesn't change. All right? So if we have something like this, I want to find all the zeros of f of x. You can x to the fifth plus x cubed plus 2x squared minus 12x plus 8. What zeros do I know? They gave me a zero of 2i. What else do I know? So if I know 2i is a 0, what else do I know? Absolutely. Chris said, right? Whatever's in front of that imaginary part, right? 2i is a 0. I also know that negative 2i is a 0. So I have two zeros right now. What do I do once I know a 0? What do I do, folks? We did this yesterday.
On how many zeros now?
Synthetic division. Right? I know a 0. Use synthetic division. Bring down that polynomial, right, to a lesser degree. Keep on going until I hit x squared, and then I can factor that or use my quadratic formula. So in this case, we have 2i is a 0. And what are my coefficients? 1, 0. I left a little space in there. Why? Because I'm dealing with a complex zero. It has what? Two parts to it. A real and an imaginary part. So I don't want to add up the reals with the imaginary. You want to keep them separate. So here, regular synthetic division. What do? Drop down the 1. Multiply, giving me that 2i. If we want to write it at 0 plus 2i. Right? And then what? You guys were here yesterday. So 0 plus 2i is just my 2i.
4 squared.
Negative 4. That's it. The 2i times the 2i gives me that 4i squared. I squared is negative 1. So that gives us a negative 4. Sorry? Negative 3. So negative 3 times 2i. What's that?
2 plus 6i, or 2 minus 6i.
Again, don't forget that's like a 0 minus 6i, so 2 plus 0 minus 6i, as Stephen said, 2 minus 6i. And now my 2i times 2 minus 6i.
4i minus, or plus 12. Oh,
Got it? Forget standard form. Always write your complex number in standard form. So 12 plus 4i? Absolutely. Now what?
4. Negative 8.
This is a zero, folks. So especially when you're doing complex numbers, or they gave it to you as a zero, you should always wind up with a remainder of 0. If you did not, and they gave you the 0, that's where you say, okay, I better go back and check my work. You come up with some sort of remainder. So my 2i was a 0, so now we came down to a what degree polynomial? Here's my constant term, right? Here's my first degree, second, fourth degree polynomial. Can I factor that? Especially with all these i's in here? Probably not. Do we know another 0?
Yes.
What is that?
Negative 2i.
Negative 2i. So we can go ahead. Divide by negative 2i. Using these new coefficients, right? Instead of rewriting the problem. So, drop down my 1. Now we're down to a third degree polynomial. So now what? We exhausted all the i's it gave us. If you can factor it, great, but that's x cubed minus 3x plus 2. That's going to be a simple factor. What do we do, folks? We did the stuff yesterday.
Find another 0.
We have to find other zeros. How do I find zeros from this polynomial? Using what theorem? Rational zero theorem, which tells us what? Find all our rational zeros, possible rational zeros by p over q, where p is my constant term, q is my leading coefficient. Leading coefficient is 1, so we're just looking at the factors of my constant term, factors of 8. My factors of 8. So we have ourselves 8 choices to choose from. So hopefully get this third degree polynomial down to a second degree by dividing by its 0. What number? Do we know? Or do you just plug and chug until you get there? Take a look at these. Look at my coefficients. What do I have? What numbers do I have? If I add them up, what do I get? I get 0. So in other words, if I don't change them, and I just use them the way they are, I'm going to wind up with 0. So what number will not change any of them? No. These are the type of stuff you can look for as patterns, right? So here, let's see if that works. So if we divide by 1, using that as our 0. Tough one here, folks. Sure enough, that actually works. But now we have what? We have ourselves with that 1, 1, negative 2, what is that?
Trinomial.
It's a trinomial, but what degree? Second degree. This is my x squared plus x minus 2. And again, we're looking for the zeros. What is this factor to? It's a tough factor, I know. So here we come up with x equaling a negative 2, x equals 1. We also used what as our zeros? Oh, we used a 1 before, right? So there's another 1. Sorry. 2i. And negative 2. So, again, I started off with a 5th degree polynomial, right? I should make sure that I do have those 5 zeros. This is what the problem asks as far as finding the zeros. If I wanted to write it in factored form, express my polynomial, what would I write? X equals negative 2 becomes, right, because it's x minus whatever that value is. So x minus negative 2, x plus 2. For my 1s, there I have it in factored form. This particular problem asks us to find the zeros, which we have right here in the red, but sometimes you do need it also in factored form. Question? We want to find the zeros of f of x equals x cubed minus 4x squared plus 21x minus 34. Given that 1 plus 4i is 0. What else do I know?
1 minus 4i.
So, I have myself a cubic, I have myself a 3rd degree polynomial, I have 2 zeros, should be a piece of cake, right? I don't have to look for any more zeros, do I? It's once I get down to the last division, I should have a linear, I should actually have the 3rd 0. So, dividing by that first 0, 1 plus 4i. My leading coefficients, 1, negative 4. Need some room, 21. Need some room, negative 34. Drop down to 1. Now what? Stephen said, I need to multiply, right? So I have my negative 3 plus 4i times 1 plus 4i. You guys know how to FOIL? You tell me what we get. So what do we get, folks? Yes, no? Negative 19 minus 8. Say, I saw some of you did not have that. Again, just foiling it out, right? 1 times negative 3, negative 3. 1 times 4i. 4i times a negative 3. And then 4i times 4i. My negative 3 plus 69 squared. 69 squared is just negative 16. So there's my negative 19. And here we get that negative 8i. So it just becomes foiling and simplifying, right? So here we have that negative 19 minus 8i. Not 81, but giving us what are we going to do again? So we already did. You FOIL this one out. 2 minus 8i times 1 plus 4i. You should wind up with 34. Again, was that something that we were expecting? Absolutely. If it's a 0, that remainder needs to be 0. So if you come up with some other number, go back and check your work. So, we now have a quadratic going. I have my constant term, my x squared. Can I just write this out and solve since it's a quadratic? Those coefficients look a little bit intimidating there as far as trying to solve that quadratic, right? As far as using negative 3 plus 4i, 2 minus 8i. Here it's just simpler to go ahead and divide by our other 0 of what? 1 minus 4. Out down to 1. Once again, since we know it is a 0, we better wind up with a remainder of 0. And what is this right here? This is just x minus 2. So again, if we're looking for that 0, that just means x equals 2. Absolutely. So my zeros are x equals 2, x equals that's what the problem was asking us for. Again, if I wanted to write them as factors, my x equals 2 is, sorry, x minus 2. My 1 plus 4i, x minus 1 plus 4i, x minus 1 minus 4i. If I am going to multiply this, for whatever reason, you're going to come up with a polynomial, or you're going to totally condense it. Don't forget, you have to distribute your negative. Right? So you'd actually, if you're going to multiply it out, which we're not going to do here, this becomes what? X minus you may see stuff like this, perhaps in your homework or somewhere, but this is how you want to go ahead and before you multiply. All right. But again, this particular problem just asks us to find the zeros, which we did right here at x equals 2, 1 plus 4, 1 minus 4. Questions? All right, let's work backwards. Here we're going to find a 4th degree polynomial with real coefficients, It has a negative 1, 1, and 3i as zeros. First things first, it says we're looking for a fourth degree polynomial. How many zeros were given to us? I need to find that fourth. What is that fourth? Negative 3i. Remember, complex zeros occur as complex pairs, or complex conjugate pairs. So now we have all four. So what do I do? Write them in factored form. So my x equals minus 3i. I also have positive 3i, so that's my x minus 3i. And then x equal to negative 1 becomes so there are my four linear factors. Doesn't matter how I multiply. Which ones I multiply with. Multiplication is associative, right? As far as it doesn't matter which factors I multiply. So in this case, we should probably do what? What? It's pretty much like an error. As far as the complex numbers, it's a complex number. So here my x plus 3i times x minus 3i is what? Absolutely. That's how our complex numbers behave. As you can see here, right, when I have my first term squared and my second term squared, and if it's plus, it behaves pretty much just like our difference of squares, but with imaginary numbers. Likewise, with my x plus 1 times x minus 1, so here we have x squared plus 9 times x squared minus 1. FOIL out. X to the fourth minus x squared plus 9x squared minus 9, giving us a polynomial, fourth degree polynomial, given zeros, gives us that x to the fourth plus 8x squared minus 9. Is this what we're looking for? If you didn't circulate this. So, just expressing the zeros as a factor and multiplying them on out, that's all you have to do. Here we want to find the third degree polynomial. Integer coefficients. That has 2 and 7i as zeros. You guys tell me what you get. Looks like most of you got it. So again, I have my extra my extra 0 of, give me a second I, so there are my factors. And multiplying the complex conjugates, we come up with x squared plus 49. And so then when we multiply this on out, What do we get, Sean?
X to the third minus 2x squared plus 49x.
Alright, we get that x cubed minus 2x squared plus 49x minus 98. Tough stuff, right? That's it for finding the zeros of polynomials. Again, we've already done that stuff before yesterday, but now we've also incorporated looking at those complex conjugates. Questions? All right, since you guys are so excited about doing this stuff, here you go. Only 6 problems here.